Alright, so this is my first attempt at recording this. So if you missed class, we discussed chemistry, kind of an intro to chemistry, and if you look at chemistry, basically you're just studying chemicals. And those chemicals can all be found on the periodic table of elements. That's what we're looking at, is elements. So you can see here's a nice periodic table. If you were in class, we cut out a periodic table and pasted it into our notebook, and right away I can already see a flaw with this periodic table. The alkali metals, which are very, very reactive in water, as we saw in that video, you can see they put hydrogen, colored it as an alkali metal, but we all know that hydrogen is a gas. But we're not terribly concerned with any of these metals in biology class. We're more concerned with the elements of life. And the main element of life is carbon, another one is hydrogen, another one is nitrogen, oxygen, and to some lesser extent we also have phosphorus and sulfur inside of any living organism. And we call this schnapps. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. So with today's little lesson, what we're going to basically do is be able to differentiate between the atomic number, which you'll find on the periodic table, it is the smaller number, and the atomic mass, which is going to be slightly larger. Okay? So hopefully by the end of this little discussion you'll be able to answer your essential question: how are the atomic number and the atomic mass used by chemists, and also for any type of science student? So the atomic structure. Basically, when we look at an atom, we have two main areas. We have the nucleus. Okay, and the nucleus you can see is right here. And inside of our nucleus we have two subatomic particles. We have the protons, which have a positive charge, and so from now on, whenever we denote protons in any of our assignments, we're going to put a little p here and a plus. That way you know we're talking about these guys. The other subatomic particle in the nucleus are the neutrons. Now the neutrons have no charge. I like to think of them as just kind of filler inside of the nucleus. So from now on in class, it'll be a lowercase n and a 0 symbol to represent that they have no charge. Alright, so those are the subatomic particles inside the nucleus. The other particle are the electrons. Electrons always fascinate me because they're the ones that are available to do work for chemists. So they have a negative charge. I think I put that too close, but that's okay. So from now on you'll see me denote them with an E, so that's electron, and a negative symbol. And you can see where they sit. They sit outside of the nucleus in this thing called the electron cloud. I'm not going to get too specific about the electron clouds. In this class we're more focusing on basically what are known as energy levels. So erase that. Each of these represent an energy level. So this would be the first energy level. Alright, scrolling on down. So if you look at the periodic table, you'll be able to see any element on the periodic table. First, you'll be able to notice where it is, or be able to recognize it by its elemental symbol. And a lot of these elements have their names, their symbols in Latin, even though we pronounce them in English. But we're lucky with helium here. This is helium. The first two letters, as you can see, make up the element symbol. The first number of concern is the atomic number. The atomic number for helium is 2. It's also known as the proton number. So it tells me the number of protons for an atom of helium. So helium has 2 protons. It also, what's interesting about the atomic number is that it also tells me the number of electrons. Protons and electrons always have to equal each other inside of an atom. If they're not the same, then we have what is called an ion. And we'll get more into that in our next discussion. So if we have 2 protons, it's going to have 2 electrons. But in order to figure out how many neutrons it has, because remember we said up above, 3 subatomic particles, protons, electrons, and neutrons, we need to figure out the number of neutrons. And in order to do that, we're going to take the atomic mass, we're going to subtract that from the atomic number. Okay? We're going to go all the way down to here. So neutrons equal atomic mass minus atomic number. You're going to want to put that formula into your notes. So if you need to pause the video, or if you want me to just, I think I'll just let you pause the video and let you write that in to your notes. Now we'll come back up to helium, because we weren't done with that. So 4 is the atomic mass minus 2. We're not going to concern ourselves with this decimal for this class. That has something to do with all the isotopes of this element found in nature, but we're just going to round up to the nearest whole number from now on. So 4 minus 2, well, that's pretty easy. That equals 2. So for an atom of helium, it also has 2 neutrons. All of them are equal. It has 2 protons, 2 electrons, and 2 neutrons. Pretty easy if you ask me. So just one more thing to reiterate here. Number of protons, which is the positive charge, must equal the number of electrons. So for hydrogen, it's got 1 proton, it's got 1 electron. For nitrogen, it's got 7 protons, it's going to have 7 electrons. For sodium, it's got 11 protons, it's going to have 11 electrons. Those two numbers are always going to be equal, unless we're talking about ions. Alright, so here I've got an atom of carbon. Let's do a little more practice. Practice doesn't make perfect, it just makes permanent. So what I'm going to ask you in class is to go ahead and denote carbon. And you're going to put down its atomic number and its atomic mass. You can always find those on the periodic table. So if you look all the way up here, we can find carbon. It's located right there. I'm going to grab this eraser so we can see the 6 and you can see the 12. Alright, back down to our problem. So, therefore, the atomic number is going to have 6 protons. It's going to have 6 electrons. But I need to figure out how many neutrons it has, but I know this is going to be easy. 12 minus 6, well, that's just going to be 6. So it has 6 neutrons. Let's try a little more difficult atom. Let's look at radon. Radon is one of our noble gases. We'll talk more about the specifics of noble gases later. But you can see here is radon. It has 86 and 222. So 86 is its atomic number and 222 is its atomic mass. So we have 86 and 222. So looking at protons, those are going to equal 86. Electrons are easy. Those are going to equal 86. But my neutrons, I'm going to have to go 222 minus 86. So 12 minus 6, well, that's easy. That's 6. This becomes a 1 because I borrowed 10. Can't take away that. This is going to have to become a 1. This becomes an 11. 11 minus 8 is 3. So 136. An atom of radon has 136 neutrons. Pretty easy. Alright, so this is what we get really into the nuts and bolts of this class when we're talking about chemistry. They're the valence electrons. And these are the electrons remember, they're negatively charged. We'll put that in there. That are found in the outermost energy level. And I think in the video we watched they called them shells, if I'm not mistaken. So these energy levels, for our class, we're probably going to stop at the 4th energy level. So we're on, if you look at the periodic table, we're not going to go any higher than this in this class when we talk about energy levels, because this is biology class. We're going to kind of keep it simple. We have some rules for valence electrons. How many fit in each of those energy levels? In the 1st energy level, you can only fit 2 electrons. Once those 2 electrons fill up that energy level, the element will move its electrons to the next energy level. So we'll be talking about a different element. We have the 2nd energy level. Oh boy. It has 8 electrons. Okay? I forgot the G there. Moving to the 3rd energy level. It can fit 18. But in the outermost energy level, okay? We're not going to talk about S and P and D orbitals here. It can fit 18 electrons, but only 8 are the ones available for us to do work, and so on and so forth. We'll stick to 8 electrons, which is known as the octet rule. 8 electrons in outer, oh, ran out of room again, most energy level. Okay? Give you a minute to write all that stuff down. Once again, don't worry about that. We'll stick to the rule of 8. Alright. If you need to pause the video, pause it right now, because I'm going to move forward, because I got stuff to do today before school starts. So let's talk about free valence electrons. Now these are the ones that are unpaired. Unpaired valence electrons. So they're still in that outermost energy level, and these are the ones that are available for us to do work as chemists. They're the ones that can form bonds. We're going to add that. The electrons that can form bonds. Alright, so let's go ahead and take an atom. Let's take an easy one here. I'm looking over at the periodic table. I am going to look at beryllium. I like beryllium. It's an alkaline earth metal. Its atomic number is 4. Its atomic mass is 9. So therefore it's going to have 4 protons. It's going to have 4 electrons. And 9 minus 4, well, it's going to have 5 neutrons. So in this case, not all of them were equal this time, like in the previous example with carbon. So we're going to go ahead and we're going to set up our model. My model is a little bit different than the one that I pulled off of the internet. Here you can see the model I pulled off the internet. Mine's going to be slightly different than that, because I like to show electrons that become paired up. And when they come paired up, they're kind of locked together. And so to note that, I put a nice little circle around paired electrons. So let's use beryllium. And the first thing you need to do is put down in your model is your nucleus. So it has 4 protons. And it's got 5 neutrons in the nucleus. I'm going to switch to a different color to show that we're outside of the nucleus now, and we're starting to move into that first energy level. And we had those rules. You can only fit 2 electrons in the first energy level. I have 4 electrons to distribute. And if you looked at this example up above, they have these 2 electrons there, but they're not paired up. So I'm going to pair mine up because I like to do it like this. It's easier for me. So I'm going to put 1, now I'm going to put its pair right there next to it. Almost looks like a couple of eyeballs on top of this. And then to show the pairing, I'm going to put a circle. So this is a paired electron. We'll just say paired electrons. That's easier. It shows 1 and 2. So the first energy level is full. So now I need to move to the second energy level. Because I have 4 electrons, I've only put 2 into my model. So now I need to distribute 2 more. And I like to start at 12 o'clock. So I start at 12 o'clock. There's 1. So I've used up 3. And I'm going to put another one over here. And this is a mistake a lot of students would make, is that they would pair those up right away. But you start at 12 o'clock, you go to 3 o'clock, then you go to 6 o'clock, then you go to 9 o'clock, and then you would come all the way back, I'll put some arrows in here, to 12 o'clock if it was a different element. But in this case, we are talking about beryllium and beryllium only. So beryllium has 2 valence electrons, and coincidentally, they're not paired up at all. You can see they're sitting here, they're free. So it has 2 free valence electrons. And I'm going to be asking you this on a worksheet in class. And if you miss that unit also, you'll find that piece of makeup work on the Google site, I guess. I get a little confused with Google Sites and Google Drives, but basically they're connected to each other just like our paired electrons. So I'm going to try one more before I leave you guys hanging in the breeze here. Let's try an atom of oxygen. So we can see oxygen. If I look over at my periodic table, its atomic number is 8. Its atomic mass is 15.999. I'm going to round that to 16. So 8 and 16, I know that it has 8 protons. It's got 8 electrons. 16 minus 8, it also has 8 neutrons. I got lucky that time. All of them were nice and easy. So I'm going to draw my nucleus. I'm going to put my 8 protons there. I'm going to put my 8 neutrons there. I'm going to grab a different color. We used yellow before. I'll stick with yellow. And I'll go to that first energy level. And in that first energy level, I'm going to go up here. I'm going to put a box around my 8 electrons because that's what I need to distribute. I put in my first 2, and I'm going to pair those guys up right away. They're paired up. Can't use those for bonding. They're happy where they are. They might move up in energy level and give off some light or some heat as they come back down. We can talk about endergonic and exergonic reactions sometime later in class, but for this part, let's not focus on that. So I used up 2. I've got 6 left. So I'm going to move to the second energy level. And just like before, I'm going to start at 12 o'clock. So 1. Go to 3 o'clock. Then go to 6 o'clock. Then we go to 9 o'clock. I've used up 4 of them. I had 6 to distribute. So I've got 2 more. And this is where they start to pair up again. There's a pair. There's a pair. So let me just check. Once I pair these up, I'm going to put circles around them so I know that those are paired. And now it's pretty easy for me to see the free valence electrons. Let me just back up a second. I'm going to double check and use this red. So I got 1, 2, 3, 4, 5, 6, 7, 8. Good. I used up all 8 of my electrons. So, back to my pink. I know that this one here and this one here are unpaired. Unpaired. And those are the ones that chemists look for. Those are the ones that are free to do work. They're free to form bonds with other elements. They're going to look for other elements to form bonds. So this one has a total of 6 valence electrons and 2 free valence electrons. Okay, you'll have more time to practice this stuff in class. So don't worry about it right now. If you're still struggling with this, maybe watch the video again, or we can go ahead and discuss it in class when we have more time. All right. So let's go ahead and fill out our flow diagram. So the atomic number, that's the smaller of the two numbers, it's going to tell me the number of protons. Protons have to equal electrons for any element. Okay? If they do not equal, they become ions. When we look at electrons, there are electrons in the outermost energy level. And we call those valence electrons. Sometimes in the outermost energy level, some of those electrons become unpaired, and they become known as free valence electrons. So we're going to put unpaired. This is just a little review. Valence electrons. Now the atomic mass, what a chemist might use that for, if you're in my class, you're going to use this to find the neutrons. And in order to do that, you subtract the atomic mass. I'm going to abbreviate. The atomic number. Now that symbol means number, not hashtag, for those of you that know things. You subtract those and you get the number of neutrons. Alright, so I hope that was helpful. Hopefully you took good notes during this because you can use them as a makeup unit.